Okay, thank you all for having me. Really nice to be here. I'm really excited about meeting all of you other Python enthusiasts and some people from the industry. So my name is Magdalena, and I wanted to share some experiences I have from working in mostly on-call engineering and site reliability with you. So as I said, my name is Magda or Magdalena, and I've been working as an engineer mostly in backend and machine learning context since 2017. I actually did a coding bootcamp in Stockholm, so it feels nice to be back here, mostly working in Finland since then. And nowadays I work as a senior software engineer in Volt's item recommendations team. I don't know how many of you used Volt or tried Volt for deliveries. We deliver food, medicine, flowers, electronics, almost anything in a lot of different EU countries, also some countries in Asia nowadays. In addition to this, I also teach some courses at Åbo Akademi University, including their machine learning courses. And specifically related to the talk today, I do on-call engineering for Volt's consumer group on-call rotation. And this is my cat Salem, who is my support person when I do on-call. So the topic I wanted to share about today is SRE, or Site Reliability Engineering. Maybe some of you recognize this term from very big-scale Google-style documents or books. But essentially, what I mean when I say SRE is building and maintaining reliable systems at scale. And usually when I say reliable systems, I mean systems dealing with, for example, money, or systems that have very high availability requirements in general. So Volt is a very good example of a system that's being used in several different countries, in several different time zones, catering to basically 3 different important groups of users. We have our end users or consumers who are ordering things off the app, but we also cater to our merchants who rely on us as a source of orders, and as well as the couriers who rely on us as a source of work and income. So if I get into the topic of SRE, I have a few kind of hot takes to start with, and that's that when you work with a service, maybe how many of us are backend engineers in this room? Like backend, API, REST, gRPC, okay, the majority. So my hot take of today is that as a person developing that service, you should always know these things about your service. Firstly, understanding what users your service has, including the use cases in case of larger scale companies. Like in my team, we are maintaining the personalization service for Volt. And some of our users include the venue page. We also serve the discovery page and the teams working with the cart and checkout functionalities. So it's important for us to know what kind of user groups we have and what kind of use cases we have. And through that also knowing what fallbacks are in place in case we kind of fail to give those users what they need. And this is actually a typical check that we do when we kind of verify our systems before big scalability events. Is we go in and check, do we have some new users? Do we have some new use cases we were unaware of before? And we will check what fallbacks they have in place. Because it has happened that we go into a larger scalability events, such as Valentine's Day or New Year's. There has been a new use case, but they haven't implemented a fallback, which means essentially if our service fails, it leads to bigger problems down the path. Another thing I think every engineer of a team should be aware of is if your service fails, what are the different symptoms that the overall system will give from that? One example could be our checkout recommendations. If we fail to provide those, we won't have recommendations visible in the checkout page. And that's kind of a sign that our personalization API isn't feeling that well. Another hot take, I think every engineer should, if woken up in the middle of the night, have some kind of understanding of what a normal requests per second RPS rate and latency expectation for the service is, so that when you see the monitors, you can kind of spot anomalies or different kinds of like symptoms of the system not working as expected. And of course, good alerting and monitoring systems help a lot, but I think these are kind of things that you should feel comfortable knowing, or at least have a very fast way to find out. So in this talk, I'm going to talk about two different kind of cases for site reliability. I'm going to talk about the good times of reliability engineering, which includes making performance improvements and performance as a topic in general, as well as load testing. I actually have massive FOMO because there's a load testing talk going on somewhere else at the moment, so it's a bad luck that I missed that one. And then for the bad times, I'm going to talk a little bit about what on-call engineers kind of see when they look at your service, and incident resolution support tools like runbooks. And I'm also going to talk a little bit about our post-mortem practices that we have for any kind of consumer reaching incidents. So let's start with the good parts and look a little bit at performance and cost optimization. So during the past 4 years, I've worked mostly in machine learning projects, and machine learning has this kind of specific traits that normal backend engineering doesn't have. We have the training phase. That is a specific kind of case where we use compute quite intensively, and we use it over a short period of time. And then we also have this, so to speak, inference phase, where we use a machine learning model to infer, for example, recommendations or predictions on data. And also during this inference phase, the different metrics or the requirements for hardware, memory, or CPU can change quite a lot. And hence the meme, we have some cases in which we use very, very expensive cloud compute, and it will keep you up at night if you forgot to get rid of those once you no longer need them. In my opinion, every day is a good day for optimization. We at Volt have been investing very heavily in this kind of infrastructure optimizations this year. And my first rule of thumb for any kind of optimization when it comes to infrastructure is that it's easier to impact the things that you can measure. So I would encourage you, when you go back to the office, if you don't already do this, try to see what the memory and CPU utilization rate of your resources are. For example, you have a Python backend running somewhere, and you maybe kind of like eyeball the EC2 instance type you put it on, or maybe you load tested it back in the day and used those results as an indicator of the CPU or vCPU requests as well as the memory requests. But following the consumption rate and kind of basing your resource utilization off of that is actually a really good starting point. At Volt, we use auto-scaling very heavily, so for us it's very essential to have the right amounts of resources, as those are the basis for the auto-scaling and kind of being able to maintain the performance we have over a varying amount of incoming requests. I would also encourage to take a look at your infrastructure costs. I've been an active AWS user for the past 5 years, and I'm kind of quite used to the AWS bill memes. AWS has like a bad reputation of billing quite heavily sometimes, and I think it's good for, like, even if you're just a regular like mid-level engineer on a big on a team in a big company, I think it's a good thing to be aware of like what the total infrastructure costs. At Volt, we've been trying to attribute costs to each team as well, so trying to kind of compare the different teams between each other and see if there is any anomalies or surprising kind of cost amounts in some teams, and see what that could be caused by. And the third kind of aspect of this is also the topic of stale or dead data hanging around. So I would also encourage to kind of review your data every now and then and just see what you're storing and why and how it's used. Another aspect of this cost savings is also the carbon footprint of your code. So maybe if you're not super passionate about saving a big corporation's money, you can at least get excited about carbon footprint emissions. And this is actually a feature that most of the cloud platforms do expose. So for example, in AWS, you can take a look at the billing manager. And it has this kind of emissions interface as well, where you can track your emissions and spendage rate over a time span. And this is at least something that many teams find quite motivating to game a little bit or see if we can optimize and get some quick wins here. Okay, and then I wanted to show a case example of some of the work we've been doing in personalization. So we had a case where we have a ranker that's country-based, and we operate in, I don't know the exact number, but somewhere between 25 and 30 different countries now. And you can imagine if we have a model that exists for all of these different countries, we need quite a lot of small instances for this serving, especially as we have availability in several different zones. So the amount of kind of these inference services is duplicated or triplicated across all of those different zones. So we use Seldon as this machine learning inference model server. And basically, in the Seldon default configuration, we have the actual model server. And then we have a little sidecar service, a sidecar service that does, for example, routing. So it's a service that sits next to the actual server pod, and it's kind of doing some supporting functionality for it. And implicitly, by default, the sidecar adds another 500 millicores of virtual CPU to the requests of the actual service itself. One other interesting attribute of this case was that the CPU utilization of these machine learning model servers was very, very burstable. So when the model kind of server restarted, it would peak a lot when it was downloading the new model version and then restarting it. And then after that, it kind of plateaued on a very much lower level, which also kind of led us to have a hard time estimating the required resources for it. And we had also used a kind of badly planned load test as a basis for the CPU requirements estimation. So I'll show a little bit what I mean later on, but kind of really trying to understand when testing a service, what are you testing, and are you testing a realistic use case? Because otherwise you might be massively overestimating the need for your resources. So from requesting 1,000 plus the 500 for the sidecar millicores, we went down to requesting only 300 plus 25 millicores of vCPU with no negative performance impact. And this is kind of, it sounds like a ridiculous amount. This is the utilization from, basically the red line is 2 weeks before measurement, and the blue line is like the current situation. And I think this might sound like obvious, but I think most systems can find these kind of possibilities for optimization if you use your time wisely to kind of also take a look at these reliability and infrastructure topics during normal operation time. Another topic I wanted to talk about is load testing, which is a thing that we do a lot in my team as well. And maybe a few starting points when to load test. Some teams do this continuous load testing, which is a bit robust maybe, but it kind of gives a very good indicator of performance shifts over time. So that could be integrated as part of a CI pipeline, as some very kind of small scale case. That could be one opportunity. In my team, we do load testing before scalability events, as I mentioned earlier, including Valentine's Day or New Year's or any kind of other events like this. And we try to always mimic the scenario of the specific event in the test that we build. So how to do it? We usually try to test all endpoints in proportion. This includes also countries. So for example, if we're running an A/B test in a specific country with some of the endpoints, we will try to mimic that same composition of load in the load test. So really giving it a think about what the realistic load and where it's coming kind of into the services is. We do load testing in both staging and production environments. You can fight me on this, but not now because we don't have time. But basically, we do production load tests during non-peak hours or non-business hours. It can also be done if the service is non-critical during business hours on top of normal operations, and then we get again back to the scenario thinking of kind of what can we really learn from this. But in my opinion, kind of regularly getting into the habit of load testing and also not being afraid to load test in production is a kind of healthy sign of like security in your code operations. Why to load test? Well, as I mentioned already before, noticing performance degradations or shifts in performance, shifts in latency, and also to predict the weak points and risks of the service. Again, getting a little bit back into this chaos engineering philosophy of it's better to break it myself during work hours than to allow it to break later on by the force of nature. So when I meant in a good proportion, this is what I was talking about. Here's the example from personalization API. We have, like, this is a very brief abstraction basically, but we have these different views, or these are like backend for front-end types of services in discovery, cart and checkout, and venue view. And they're all using our personalization API and basically using it as a proxy service for these machine learning models and other kind of systems we're hidden behind. So if we think about personalization service, in this case getting 100% of the traffic, when we think about a load test, we want to achieve the same balance where the ranker gets 40%, similarity service 20%, maybe others like we have some new A/B tests going on, also get like the correct amount of percentage. And on a layer on top of this, we also want to have the country-specific layer. So if we have A/B tests going on with some of these like services being present in some country areas, we also try to count the differences between, for example, if the cart view is only visible in some specific geographic areas, then to kind of take that into the mix when we plan the load test scenarios. And a little bit more about the scenarios. When we think about the vanilla load test, we think maybe about this request per second, simulating a normal business operations request amount. This is a fair example of a like regular load test. This is maybe something I would do during like a regular load test, just to figure out the resource utilization, CPU requests, memory requests, and also like a little bit of an expected latency. But on top of that, I would also encourage thinking about, for example, what happens if we do double the expected requests per second over a longer period of time. How would that impact the service? How would the scaling look? And where would we kind of eventually get to? Then we have another scenario where we have a kind of the basic load, and we have a peak somewhere kind of in between. So here you could run two load tests on top of each other, or you could do the peak kind of on top of normal kind of traffic. And the example for this could be, for example, events like Yom Kippur, where the spike is very rapid. After a day of fasting, everyone wants to order some food. Or we could just try to crank up the load until something breaks, and this is also a kind of valid load test scenario, maybe not in production or maybe not during business hours, but kind of an interesting thing to think about. Because it's always interesting to know what will be the first thing that breaks. Okay, then a little bit about when things go badly. This was a meme that one of my fellow on-call engineers sent to me. We sometimes have bad outages, and this is kind of the mood sometimes. One of the first things I wanted to mention is the topic of runbooks. Basically, when I work as an on-call engineer, what I do is I have my phone next to me when I sleep, and sometimes in the middle of the night, the phone starts ringing, and there is an alert. It's maybe 1 a.m. I'm super confused in general because I just woke up. And what I really want to know is kind of very quickly, when I see an alert, I want to know the business impact. I want to know if this alert is possibly flaky. I would like to know kind of how the architecture in general looks like and where I can get more support for my investigation, and what actions I could take next. Perhaps also who the emergency contact for the service is. And I wanted to show you like one kind of concrete example of a incident procedure at Volt. So here we have a Kafka consumer lag alert. So we have lag growing in a specific consumer group. And this is kind of what I see when I first open the alert interface. When I go further into the alert, I can get some more details on it. And here I can see the metrics, I can find a runbook, and I can find general guidelines. So let's start by looking at the general guidelines. This could be if it's a specific alert like horizontal pod autoscaling capacity running out, or Kafka consumer high lag. We could have these like generic kind of informations documented about what this could be about, what the impact could be. But we also want to take a look at some more specific runbooks. So attached to each service, we have the so-called runbook. And this is part of the service's repository itself. So here we could have stuff like a summary of the project itself, the emergency contacts, metrics, dashboards, alerts, as well as other kind of more detailed, maybe service architecture, detailed information of the service that we're working with. And sometimes this also has direct kind of details about each alert. So for example, for this specific service, if the consumer lag is high, this has been seen before in this scenario, and this is how it was mitigated before. And another topic we have is postmortems. So sometimes we have bad incidents and it takes a longer time to resolve. And from every incident that is consumer facing and that has a business impact, we always aim to write a so-called postmortem or after death document. So in each postmortem, we want to show a detailed timeline of events. Usually the postmortem is written either by the on-call engineer or by the team managing the service itself. We also document the business impact. So for example, how many customers were impacted, how much kind of, or how many merchants, customers, or couriers were impacted by this outage, and what the kind of monetary loss approximately could have been. We also try to find the so-called blameless root cause. And of course, that doesn't mean that we hide behind responsibility, or we kind of don't take responsibility. We very much do. But the point of the post-mortem is not to point fingers. It's more to kind of understand why it happened and how it could have happened, and what we need to do in the future to prevent these kind of incidents. And as well, we want to always look at any follow-up action points. So what kind of takeaways do we have? Is there any tickets that are created based on this? And basically where we move from here. So here's the example of a postmortem document that we use. Here you can see it starts with a brief summary, then it goes to the timeline where kind of the events are described by timestamp. We also try to follow the time to detect, time to engage, and time to fix. And then we go in for a deeper root cause analysis. And all of these documents are only as useful as we make them. So instead of just kind of one engineer writing this up and then forgetting it in Confluence, we always have a weekly meeting on kind of how to move forward from there. And we try to knowledge share a lot. So for example, all the on-call engineers for consumer group will be reading all the postmortem documents that the group has. And this way we try to really kind of make sure that other teams also know about incidents, so that they can see perhaps they have a similar pattern or a similar vulnerability going on in their own code. So in conclusion, I think it's generally a great idea to always prepare for the bad times during the good times, and be very like kind of proactive when it comes to reliability engineering. So not only kind of waiting until something blows up and then being upset about it. One other thing that I really firmly believe in is breaking your own system before nature does. This was not a talk about chaos engineering, but it's very, very closely related. And kind of load tests to a certain point are part of that same family of work. And then also, when there is an outage, when there is an incident, do share knowledge about it, make sure everyone learns from it, and kind of make sure it's documented and kind of shared in the team and company. So that was all I had for today, and like, I don't think we have time for, I don't know if we have time for questions, but please do come and say hi, and I'm going to be here for just this day, so it would be nice to meet as many of you as possible. And quite related to that, we have 3 big tech hubs at Volt. So we have one in Stockholm, one in Helsinki, and one in Berlin. And we are actively hiring both Python backend engineers, but also other backend and ML roles. So would be happy to work with some of you in the future. But that's all for me.